Hello everyone and welcome back. If you have followed my YouTube channel, you saw that I created a digital clock by using two timers for 8051. In that project, I use assembly language. Now I'm going to write the same project but this time with C language for 8051 microcontroller. So this is the schematic of the project. As you can see, we have a multiplex 7 segment with 4 digits and it's connected to the 7447 BCD to 7 segment decoder. And we control the anodes of the different digits of this multiplex 7 segment to uh, actually display the corresponding data on each of these 4 uh, 7 segments. And we need a scan subroutine to do it in a very fast way in order to uh, display 4 digits on the same time on this module or display module. Also, we have 4 push buttons in this project, 2 for setting the hour and 2 for setting the minute of the time. So up and down for minute, hour, and up and down push buttons for minute. And if I start simulation, you will see that you can see that there is a time here, and by this button, I can increase or decrease the hour part. After 0, it become 23. And by this point, I can increase the minute part. After 59 becomes 0, and after if you decrease it from 0, it come back to the 59. If you remember, in that project I use one timer to display the to scan and refresh the 7 segment, and another timer for creating the second, minute, and hour. Let's see how we can do it in the C language. So first of all, I assign some names to the push buttons and also to the anodes of the 7 segment. And these are the variables that I'm going to use in this project. Turn, digit 1, digit 2, digit 3, digit 4, second, minute, hour, and additional variable millisecond. In C language, in order to mention that a subroutine is actually the interrupt service subroutine, we use this syntax. First, mention the void keyword, arbitrary name for your subroutine, then interrupt, and you need to put a number here. For the timer 0, you should put number 1 here, and for the interrupt service routine of timer 1, you should put number 3 here. As you know, we have 5 interrupt sources in 8051. External 0, timer 0, external 1, timer 1, and serial port. They are numbered from 0 to 4. So interrupt number 1 and interrupt number 3 are corresponding to the timer 0 and timer 1. So this is the interrupt service routine for timer 0. Whenever timer 0 uh, generates an interrupt signal, the system automatically invokes this subroutine. And I have another one here for timer 1. So this subroutine will be automatically executed whenever the timer 1 generates an interrupt signal. Let's check each of them. If you remember, timer 0 is set to generate an interrupt every 5 milliseconds, and each time we only display 1 digit and move back to the main program. That digit will be displayed for 5 milliseconds, and then we come back in after 5 milliseconds and change the display and show the second digit. We will continue this procedure until all of the digits are displayed, and this after that we come back and do it from the beginning. So for this purpose, I declare a variable turn, and turn can be number between 1 to 4. If it is 1, as you can see, I activate the first 7 segment anode and deactivated the other ones, display the digit 1, and we move out from the switch case structure. And here we again set the timer to generate another interrupt after 5 milliseconds. This is minus 5000 in hexadecimal that I put in the TH0, TL0, the registers of timer 0. So next time the interrupt, the timer 0 generates an interrupt, the turn will become 2, and this time we display the second digit. Next time we display the third digit, and finally after we display the fourth digit, here I change back the timer, the turn to the 0. So in the next time that timer 0 interrupts the system, we display again digit 1. So digit 1, 2, 3, 4, and come back again digit 1, 2, 3, 4. It will be repeated every 5 milliseconds. And here, this is the uh, interrupt service routine for timer 1, which is responsible to generate second, minute, and hour. But as you know, we cannot set a timer to generate an interrupt every 1 second because we have a 16-bit timer. So here I set the timer 1 to generate interrupt every 20 milliseconds. So this is minus 20,000 in hexadecimal, and I split it and put it in the TH0 TL0. So after each time that timer 1 generates an interrupt, sorry, this part, this is minus 20,000. Every time that timer 1 generates an interrupt, we increase a variable millisecond. So it is started from 0 and now it's become 1, and we find out that 20 milliseconds is passed. Here I check, is the value of the millisecond become 50? Whenever it's become 50, it means that 50 times 20 millisecond is passed. So it is exactly 1 second. So when this condition is satisfied, we increase the variable second and again initialize the millisecond variable to 0. Of course, after 60 seconds, we should change the variable second to 0 and increase the minute. And when the minute becomes 60, we should increase hour variable. And when hour becomes 24, we should initialize it again back to 0. Don't forget to call convert every time that you change the variable minute, hour, or hour. Actually, this convert, as you can see, only uh, extract the left digit and right digit of the hour, and the same thing for the minute, and store them in digit 1, 2, 3, 4. And these are the variables that are used in the interrupt service routine of timer 0. As you can see here we display the content of these 4 variables. So hour, which is the number between 0 to 23, will be divided into 2 sections. The left digit in digit 1, the right digit in digit 2. Minute, which is a variable between 0 to 59, will be divided into two sections, one for the digit 3 and another for digit 4. So this is the interrupt service routine for timer 1. And here in the main program, first I enable the interrupt for timer 0, timer 1, and also this line, let me put it here. So I make it possible for timer 0 and timer 1 to generate interrupt. Here I set the timer 0 and timer 1 to work as a 16-bit timer, initialize them, timer 0 for 5 milliseconds and timer 1 for 20 milliseconds. And here we run them. Timer run 0 is 1, timer run 1 is 1. So they are started from this point, and after 5 milliseconds, they will generate an interrupt for the timer 0 after 5 milliseconds, and for the timer 1 after 20 milliseconds. They interrupt the system, and the system move to the interrupt service routine and run that program for us. Here we initialize the other variables that we have. Turn should be initialized with 0. Hour and minutes are filled by some optional number, for example 1255, the first number that you can see on the 7th segment. Second should be initialized with 0, and we call convert to display these 3 or 4 actually values on the 7th segment, 2 digits of the hour and 2 digits of the minute. In the main program, we have an infinite loop, as you can see from this point. And inside this infinite loop, we check the status of the push buttons. I name them hour up, hour down, minute up, minute down. If hour up is pressed, hour variable should be increased. Of course, we should check it. If it is 24, come back to 0. Don't forget to call convert whenever hour and minute are changed. And here I'm waiting until the hour up key is released. This is the same for the minute hour down. Decrease 1 unit. If it is -1, change it to 23. Convert it and wait until the hour down key is released. And this is exactly the same thing for minute up and minute down keys. So this is the implementation of digital clock in C language for 8051. Let me run the code, but instead of every 16 seconds, let me increase the speed. Every 2 seconds, the minute will be changed. So by this way, we can see the status of minute and hour faster. 56, 57, 58, and then it should be 13.